Welcome to AI Frontiers. Today we embark on a journey through the latest advances in artificial intelligence, spotlighting 11 breakthrough research papers published on August 10th, 2025. In this episode, we will explore how language models, intelligent agents, and autonomous systems are redefining negotiation, logic, cybersecurity, medicine, and evaluation. Each segment builds upon the last, guiding you through the evolving frontiers of AI. In this episode, a curated selection of 11 AI research papers published on August 10th, 2025 will be examined. Key themes include how artificial intelligence reasons, plans, and adapts across domains such as strategic games, cybersecurity, and medicine. Listeners will discover how large language models are progressing from text processing to strategic action and learn about ongoing challenges in evaluation, reliability, and deployment in real-world settings. Each theme, methodology, and finding connects to the broader future of intelligence systems. Artificial intelligence strives to emulate human-like reasoning, learning, and planning. Today, AI influences sectors including healthcare, cybersecurity, finance, and entertainment, pushing the boundaries of language understanding, visual perception, multi-agent collaboration, and autonomous decision-making. This episode focuses on recent advances in how AI agents learn, collaborate, and adapt to complex tasks, emphasizing the ever-growing significance of the field as systems tackle real-world challenges. The first major theme centers on language models as agentic reasoners. Research by Duffy and colleagues demonstrates that large language models can play diplomacy, mastering both negotiation and strategic planning. Multiple studies show these models coordinating in multi-agent decision-making scenarios, marking a shift from passive language understanding toward active, strategic reasoning. Researchers are now exploring how textual prompts can be crafted to guide agent behavior, introducing the key concept of agentic reasoning, where large language models function as autonomous, decision-making agents. The second theme highlights the automation of complex human tasks. Sider and colleagues present cs.AI, which models and solves logic puzzles using only plain English descriptions. Generative models are now contributing to strategic planning and specialized workflows, enabling AI agents to tackle tasks that previously required deep human expertise. Adaptation to new domains is achieved through prompt design rather than rigid, hard-coded logic. The key concept here is prompt engineering, the careful crafting of inputs that steer agent capabilities. The third theme addresses benchmarking, reliability, and evaluation in AI systems. New frameworks, such as those introduced by Hall and collaborators, are advancing large language model benchmark construction. Hallucination, or the generation of incorrect information, is now being studied as a fundamental computational boundary. There is a pronounced emphasis on developing evaluation protocols that are both comprehensive and manageable, with iterative benchmark design ensuring that AI systems are tested against meaningful, real-world scenarios. Reliable assessment is now crucial as AI systems grow in autonomy and societal impact. The fourth theme explores lifelong adaptation and multimodal understanding. Fang and colleagues provide a comprehensive survey on self-evolving AI agents, focusing on continuous learning and adaptation. Innovations such as Invert4TVG ground textual queries directly in video content, while EndoAgent demonstrates reasoning from medical images. Advances in memory architectures and reflective reasoning are enhancing resilience in complex workflows. And multimodal approaches are integrating text, images, and structured data. As a result, AI agents are becoming increasingly context-aware and capable of lifelong learning. Key findings from this collection of research include several notable breakthroughs. Large language models, when guided by optimized prompts, can play diplomacy without any special training, as shown by Duffy and colleagues. Coding agents are now able to solve constraint problems flexibly using natural language, a result demonstrated by Sider and collaborators. Reinforcement learning is enabling robust, adaptive cybersecurity agents, as seen in the work of Kong et al. Self-evolving agents and the integration of multimodal data are driving progress toward lifelong learning, while new benchmarks are placing a greater emphasis on critical evaluation for reliability and safety. A closer look at methodology reveals how today's AI agents learn and adapt. Prompt engineering is being used to encode domain expertise, enabling flexible agent deployment across diverse tasks. Reinforcement learning approaches, such as those by Kong and colleagues, combine offline demonstrations with online interactive feedback for continual improvement. Modular and multi-agent architectures are utilized to address large, complex challenges, while memory architectures, exemplified by EndoAgent, support reflection and context tracking. Iterative benchmark construction ensures that evaluations remain robust and closely aligned with real-world demands. The first spotlight paper is Democratizing Diplomacy, Harnessing LLMs for Strategic Play by Duffy and colleagues. This work demonstrates that large language models can engage in complex negotiation games such as diplomacy using only textual input without the need for specialized training. The impact is significant as it lowers the barriers for research in AI negotiation and planning. The novelty lies in the evaluation harness, which allows any language model, including those running on local hardware, to participate. This development opens new avenues for research in multi-agent coordination and strategic reasoning. The second spotlight is on CP-Agent, a coding agent for autonomous constraint programming, by Sider and colleagues. This paper challenges the traditional need for rigid pipelines in constraint programming. By leveraging persistent memory and dynamic tool use within a simple Python agent, CP-Agent is able to solve all 101 problems in the CP Bench benchmark using prompt-guided general coding. This approach highlights the potential for flexible reasoning agents that integrate prompt engineering and tool use, setting a new direction for the automation of complex logic problem-solving. The third spotlight features Pentest R1, Reinforcement Learned Agents for Penetration Testing, by Kong and colleagues. This research sets new standards for open-source cybersecurity agents, outperforming most state-of-the-art models in real-world security benchmarks. The innovation is a two-stage reinforcement learning pipeline, which combines offline learning from penetration testing walkthroughs with online interactive learning. This methodology enables the creation of adaptive, autonomous agents suitable for high-stakes domains such as cybersecurity. Looking toward the future, several key directions are emerging for AI agents. Democratization is making it possible for more researchers to experiment with advanced reasoning systems. Lifelong learning will be realized through self-evolving, continuously adapting agents. Multi-agent collaboration is anticipated, where specialized agents coordinate to solve complex, large-scale problems. Advances in benchmark construction are producing evaluation protocols that are both compact and comprehensive. Additionally, there is an increasing focus on ethical and safety considerations, ensuring that AI operates transparently, responsibly, and in alignment with human values. This presentation was synthesized using the OpenAI GPT 4.1 model for research analysis and narrative construction. The narration was produced using OpenAI's text-to-speech technology to ensure clear and engaging audio delivery. Potential visuals were described using Google image generation tools to guide design. All synthesized content underwent review by a human expert in order to maximize clarity and coherence. Please note that despite expert review, some oversights may persist. For further details, refer to the provided references. Thank you for joining AI Frontiers. Subscribe to our YouTube channel for more in-depth explorations of artificial intelligence breakthroughs and connect with a community passionate about the future of intelligence systems. Stay informed on the latest developments in reasoning, autonomy, and AI research. Your questions and insights may shape our next episode. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from arXiv preprint server. From neural networks to quantum computing, complex research is simplified so you can stay ahead. Whether you are a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.